I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Peace! Peace! Amen.
All right, we just finished doing a test fit by putting a piece of the material on each side of the window and slipping it into the opening we anticipate this to fit into. And we're going to go ahead and give it about another 100 thousandths in the depth here. The width, after the multiple cuts, it seems to be just enough tension to hold that aluminum frame with no issue. We moved our support out a little so that we could handle the depth. That'll be finished. Ladies and gentlemen, welcome to my job shop. My name is Keith and I'm here repairing America one project at a time. Now, the last couple weeks I've been involved in remodeling some areas in the shop here, and over my right shoulder here you can see the new set of walls, windows and doors there, and what I've created in this area here where the Rutland used to be and the bench and all of that is my new 3D printing room. I've purchased my second 3D printer just this last month, and it's actually been sitting in storage until I actually had this room built for a clean environment for 3D printing. It's a necessity. I have an oil furnace in here, and every once in a while it acts up and it kind of soots out the room. Sooting out a 3D printer is not too cool. And actually, my Ultimaker, originally I was going to run it and had it set up against the wall over by the X-Carve, and it did get sooted out, and I had to scrub the thing all the way down. I eventually put it in my apartment. I've been running it in my apartment. And so I brought it out of that as well. And now everything is in a nice controlled space. And we'll be getting into that at another time. The plastic that you saw me milling out on the KNT is for the window that's over here, a makeshift window that I wanted to add in on that side there. I wanted to have visual in and out of the printing room because it's part of the shop, and I want it secluded or closed off environment wise, but I wanted to have access to see customers coming in or any customers that like to peek in and actually see what's going on without actually opening the door and going inside. Okay, so we're gonna be covering the print room and 3D printing at another time. I actually have a customer that we've had before. We remember that month we had water pumps in here. So he has a Huber, I believe it's a scraper or a blade, antique grater. and he has brought in some worn out ball joints that the hydraulic cylinders control the blade, and we're going to make a new set of ball joints for these hydraulic cylinders. So let's come on in and we're going to get started on this project. Here's the 4 ball joints that we're going to be replacing. So we're going to make 4 new pieces here. We have castle nuts that we're going to be making or modifying for the nut that goes on the end of these as well. These are pretty worn out. You can see this ridge right here is where the pocket assembly has worn down from years and years of wear. And the diameter of this ball is not round anymore. In fact, actually it's worn almost 100 thousandths. So we're going to bring it back up to par. And what happens is this actually interferes the ball from actually moving where it needs to move. And they're running out of options, and this thing wants to repeat into the same pattern. All right. Now what we need to do is make a pattern, and we're going to be using our tracer on the closing to machine this shape. Now, I wanted to point out something and why this shows all the wear and there's hardly any wear on here. These are actually, they're not soft, but I can take the file and I can put a groove in it. And these parts, you can hear with the file, they're not marring, they're not doing, these are hardened. So the ball was the sacrificial part of the 2. Now, I don't believe that this is as soft as 1018. That's why I chose to make them out of the material that I want to. So that I got the strength as far as sticking out here, shear strength here, and wear strength here to be comparable with what I believe these originally were designed with. Well, here I got the camera back under the hood of my Wazer, and I'm setting it up, and we're in the process of cutting out our template for making the ball joints. Now, this is the very first time lapse that I've actually put underneath the cover there and watched this machine run. And I'm so glad that I actually did, because I get to see clearly what's happening underneath the cover, because sometimes the water spray and the little bit of residue from the dirt and stuff, you got 2 kinds of dirt in there. You can see the red garnet, and that's the material that is doing the cutting with the water. And then you see the black grayish sooty material floating around very, very fast. It's real lightweight because that's the plastic material in the support bed. The other thing that I really noticed here was the water level management inside this in time-lapse motion actually shows you how it drains down slightly, and then it recovers, and it keeps that control to a certain limit there. And that's pretty cool action to see that happen. Pretty much you can see that it's not real volatile inside while it's cutting, because this camera lens is staying just super clear and really giving a good view of this. Now this is 1/8 or 12 gauge steel, and I'm cutting it into fine mode, so it's taking a little extra time in its cut, because the quality of cut is the most important thing to me. And so anyway, it's really looking cool, and I'm kind of glad I did this time lapse, and it looks like we're back at the end. Okay. All right, I heard the Wazer stop, so, and there we go. We got a little bit of a mess in there. All right, let's actually, I'm going to go ahead and pop out my camera here first. All right, this is how I got you the time lapse with my Pro 11 there. All right. All right, I started the pierce right here because I wanted to come around. This is a non-important area. The flat is square with everything else, so if I wanted to, I can locate with the square. I cut this out on the fine setting because I wanted as smooth as possible. In my intro on my YouTube channel, you see me cutting the stem of those rudders that I built a long time ago, stainless steel rudder. And that pattern I cut out with the plasma cam back in the day. If you wanted to watch those videos, you could see that. And so there's a little tab on here. I'm just going to see if, actually I'm just going to get my scale right here. There we go. Okay, doesn't take much to break that little tab. This surface right here is just going to take a little bit of polishing, and then that stylus on the tracer attachment going to come down, come over the thread diameter, come out to the outside shoulder. It's going to run along that taper. It's going to sweep the radius that's down in there at the bottom of the ball, and then we're going to come up at the top of the ball. After we get all 4 of our items turned from the threaded end up halfway to the ball, we'll turn this jig around, and we're going to come and we're just going to do the one end of the ball like that. All right, let's go into the closing, and we'll set it up. And we thank our Wazer for giving us a really nice pattern to work with. All right, before I do any finishing on this part, I just took it over the bead blaster, which is real light bead blasting, and I just hit it real quick. Because you do have a tendency to have a little oxidization on the steel parts after you cut them in the water jet, because you know the environment they just came out of. The pierce, and then there's one little spot right there where it starts the radius, but this is pretty smooth. That angle is pretty smooth. Nice sharp corner here. We're not sure how we want to approach that, but that is a shoulder that the threads will come here. You have a straight shank in this area, threads in this area, all the same diameter up to that spot right there. And I had, this is a chamfer just leading off the angle of the thread. So when you start with your thread cutting, you're just going to come in with a little chamfer right there. 12 threads per inch, so you know that's going to be a pretty good little lead in, just so it's not sharp on the edge. Pretty cool. All right, you get the picture? This is 1 for 1. This is the size that it will be. I'll just put this in and out to control the diameters. Of course, the most important diameter is going to be the ball diameter. 4 inches apart. That's what I originally, I have a couple other holes drilled at this end, but from here to here is 4, 4, 4, all the way down this whole thing. So this can sit in any of the increments of 4. All right, and we may want to run it there or up here. Up here close, this is where your chuck is basically right here when this is in place. And you can make this go up and down the back of the lathe, which would change the position in between the chuck and the tailstock of the lathe as well, along the bed. All right, and we gave it a little bit of a slot because we want to be able to adjust it in and out to create our diameter. And basically, the stylus comes along here, hits here, and comes around and does this. So we know that this is 1 inch, so that's about a half. And we know that that ball is like 1/700, and it's almost like right on the money right there. So we could take a straight edge and an indicator or whatever and come across this back, straighten this with this bar, and we can rough set it that way. When we measure our diameter, we can always make sure that this run right here is parallel with the diameter and the axis that we're tracing. So that's ways that you can set everything else up as far as running true. But it'll come down, go out, come along, come in, and hit this radius. We're not going to be able to go all the way around this corner here. We're going to stop halfway up the ball here because that stylus comes in at like 30 degrees. Once you come off here, it's going to fall off fast, okay? And that'll just plunge dive your part. So you always kind of work the face on up over to a diameter. Right about there will create the stop, or we'll stop it ourselves manually. I don't have a manual travel stop on this lathe. All right, I got a wrench and a couple parallels, and we're going to come around here to the back. I'm going to bring you over on the other side, but I wanted to show you where I put the Rutland lathe for temporary use. And I was actually able to use my plug that I was powering my hot shot ovens here on the table. And so the table went out into the weld shop, and the ovens are in the container waiting for me to build a new location for all the ovens, plus the new oven that I have coming in. So temporarily the Rutland will stay here until we're ready to give this away. Now I'm still planning on giving this away, giving away a mill and a toolbox to go along with both the mill and the lathe. All right, we're going to be following up with another video on that, but I just wanted to kind of share that with you. All right, come on over here so that you can look down on this side and watch how I set up this template that we're going to cut out the ball joints with. I had picked out a couple quarter 20 bolts, and we can go ahead and adjust this thing in and out. We don't know exactly we're going to run it this way here yet, but we want to set this because no matter where we position this longitudinally on the lathe, we know that we want this to be a 1-inch diameter, and then this needs to be 1.5 inch diameter, and we need about 1/700 diameter here. We'll be looking at all of these as we're cutting, but a quick setup would be to go ahead and take this 1/2 inch, put it in here. So I'm holding the parallel against the back of my straight guide, and then I bring this in until that surface is against the parallel. So I know that that is set up for 1-inch diameter, meaning this leading edge of my support or my guide is used as 0 center line. So the stylus comes along, boom, out along here, boom, out, boom, in, boom. All right, now I got to pick out my cutter and then bring the hydraulics and the stylus into here, finding out where my cutter is in relationship to the part, determining how far I stick this out or bring this in, or how far I move and adjust this, will all come into play once I put that tool in here and get it set up in relationship to the material. Okay, I picked out my bit. I don't know where I'm going to run this yet here. Let's bring it on in. Okay, that's still a little shaky. All right, so we're touching the stylus back there to our jig, and we're just coming, and right there is coming up on our jig. So, and of course this, okay, it's, you can see I didn't even dial it in yet, but I had it chucked up here, and I'm within probably 50 thousandths of where that is. Of course, I got to face this and put a center drill in it, but from my experience of where I set up there, just letting this stick out, that's like 6 there, 2 1/8 there. I guess you just get used to things. All right, so what I want to do now is I'm going to go ahead and lightly loosen this just so I can bring this out. I want a positive amount of feed. Now I have a lot of adjustment in here, but I want to make sure that I can back it out as well. Plenty of travel. I got a lot of ways here that can come on out. It's no big deal when you run out of travel inward is to loosen these two screws up and then slide your tool bit. I keep it flat against that area so it's just coming straight in. It's not like it's following any angle like the 30 degrees that this is coming in here. All right, and it looks like I have enough material right there. So now I can put this in neutral and I can put the dial indicator on here and dial this piece in. I know I'm going to be turning it, but anytime that you're gonna turn part off apart, turn part off apart, you like to keep it coming out uniform and straight. And sometimes you don't, on a 4-jaw, if you only loosen 2 and tighten them back up, sometimes you're only within a couple thousandths. You know, I can't wait till the phase converter's gone. Not just a little bit of the background noise, but you know, it's a lot better. It's not bad since American Rotary donated the new phase converter, and it got sent here, and we've been doing okay. You know, it's been over 3 years. Right now, Eversource has everything ready on the outside of the building, and the wiring's up in place, and they were called out the last 2 weeks in a row for emergencies, but we're trying to time it with minimum downtime with Childs, my landlord. Everything else is all set, so I can't wait till we can clear off that back wall with the old electricity and get the draping wires out of there, and really neaten up this area right here, because the back of the lathe already being cleared out like we've got it is pretty amazing. All right, really nice having a lathe with 2 approaches of cutting bits. So I'm going to take and use this one first, face across here, and put a center drill in here with the tailstock, and then we can put the tailstock in here to help support this, and then we're going to come in with these this insert back here on this compound, which is the hydraulic tracer, and it'll probably cut better now that we have those jack screws tightened up on that tool block. All right, first we have it in forward. I'm just feeding it in by hand. Okay, we'll change over to a center. All right, we're going to bring the center in. Okay, now we can come in here. We can pull this bit out just so it's not making anybody nervous. And we're going to come into our edge here. We're setting a 0 on our travel dial because sometimes we back out and then just roll the carriage back, come to the 0 point, and then click the compound and come back in again. Okay, our diameter to start out with is going to be the first area we're going to touch, and it'll probably come in here and make about 2-3 passes before we got to come up over here and start worrying about this valley in here. Okay, now we put the lathe in reverse. We reverse our feeds. Now I just come in and touch. Okay, see, this comes in and it actually cut a little bit off of this face here, and then started to chamfer and then come around here. I'm going to take a 1/4 inch parallel and clamp it to the side of the bar so it'll come in and hit the parallel, and it won't be starting so far in here, because otherwise I'm going to run that bit into the center. All right, so this, because I'm asking this pattern to be center line with that, and of course the center line is in the center in relationship to reality. I clamped that parallel down in place, and you can see it there underneath the template itself. So it hasn't changed any diameters other than its starting location. All right, so we're going to come in for another cut, and this time I'm gonna create, because now I know where I'm at, so I'm gonna come in 30 thousandths per side. There we go. Okay, now I'm going to hand feed it up over to where it would come back in for that plunge, and let's make sure that are we going to be cutting yet? Oh yeah, it's going to start cutting in that radius. So, okay, just that little tiny bit. I knew we weren't far behind, okay? Okay, when I came back, that actually just followed the surface back. So you know why. Sometimes when you're backing up, you just want to get it out of the way, come back to 0, and then come back. Because you have tool pressures that will cause marks or blems on your part. You don't want that to be on your finished product. Another 30. I've got you about 8 feet away, looking down in at the right angle to get to that. That's pretty cool. I'm impressed that I'm looking at that zoom right there at 8 feet away. You're off the end of the lathe over there. Okay, here we go. We're gonna give you a shot from above at the tool bit and the stylus at the same time. Now when this comes in, you see it actually almost looks like it jumps a little bit. It comes back and it kind of settles itself, is what it's doing. Okay, I'm gonna crank in another 30 or so. Here we go. We're still about 1/8 of an inch away from that diameter right there. But then it'll come back in. Sweet radius, huh? Okay, I just checked that diameter right there, and we're at 1/400, so we're a couple hundred thousandths away from finished diameter. So we go 10, 20, 30, 40, 50, about 45 to 50 right there on the dial. One 311. the diameter here. Okay, 1 inch, 112. Okay, we're just gonna come in with 40. Take small cuts. We're going to take 10 per side, 20. We only got like 45 more to go on the total diameter anyway. The ball is supposed to be 1,700 and the material stock is 1,750. We'll take a couple thousand. We checked our diameter on the shank and it's a little bit larger towards the shoulder, which is good. The diameter of the hub and the combination between it and the other two major diameters, the shank and the ball, all look like they're within a couple thousand. So it looks like my jig is in there really straight. Okay, we just started going past the center of the ball there. All right, that's excellent. Now I can get a real diameter there in the middle and in the small section there. I'm making an adjustment because I believe that I'm measuring this diameter here on the shank is measuring close or at 1 inch, and this is measuring about 20 thousandths over, and this ball up here is actually showing the outside diameter here and there progressively are showing pretty similar signs of the progression of that 0 to 20 thousandths in here, increasing out in these diameters right here for the diameter it is. We're almost like 140 or so. So I'm going to go ahead and loosen this, and I'm going to bring this out, which will in turn pivot the pattern and compensate for the diameter difference that I'm actually getting up there at the tool bit. My guesstimate is going to start at 10 thousandths. Now we're going to fire it up. I'm going to come in on my 0 mark here. Okay, it's touching anything here. So I'm going to crank it in until it does touch. I'm going to engage it, just touch it, or let it come in and touch here. I cranked it in another 5. There it goes. Okay, I'm going to let it run right there. Okay, it's all going to be about the diameter of your balls. We were darn close here, so I'm going to make another adjustment here. I think 5,000 should do it. It's going to be close enough. I want a couple thousandths heavy on the ball because we can polish balls. So, you know, there's no problems of bringing it down to size. But the taper in the main shank is still about 7, and that 1.5 inch diameter in the middle is like right on the money, so I'm not going to snivel too much about that being a couple thousandths smaller or bigger. It doesn't matter. It's just clearance of the air. All right, here we go. Same thing. I'm just going to let it start. It'll come out. It probably, yep, it's not going to cut, but I'm going to crank it in until it does touch. There we go. Now I'm going to let it run. I'm going to put a blue mark on my compound dial right there. That'll tell me that that's the finished size, and I'm going to call this the finished cut. And our ball's at 707. We'll stay with that right there. I picked a distance to part these all off at, and here we go. Okay, that's all we're going to do on these today. We have a couple other projects in the shop we got to switch over to. until we come back with the conclusion of this project here, get her done.